Hello everyone, my name is Tisha. Today I am going to explain differentiator circuit. So this is our differentiator circuit, and we have given resistance of 1 kilo ohm and capacitance of 100 nanofarad, and the resistance is connected to the 216 pins of the op amp, and we have given a power of 12 volts. And when we given an input of 2.5 kilohertz and 1 volt peak to peak, we got this as our output. So now when we give a square wave as input and this is our output, this indicates we are using a differentiator circuit. For differentiator circuit, by taking resistance as 1 kilo ohm and capacitance as 100 nanofarad, we are varying the frequency from 500 to 10,000 and taking values of output voltage peak to peak, and we are plotting the graph between output voltage versus frequency, and we are also plotting the graph between 20 log V0 by Vi and frequency, where 20 log V0 by Vi is known as gain, and here input voltage is 1 volt, and this is our graph. Now this is a differentiator circuit using 2.7 kilo ohms resistor and 100 nanofarads capacitance, and the capacitance is and the input is given to the capacitance, and resistance is connected to 216 pins of the op amp. And when we give it, and we are given 12 volts of power supply, and when we give a square wave of frequency 2.5 kilohertz and amplitude 1 volt peak to peak, this is our output. Now when we given a square wave as our input for 2.7 kilo ohm resistor, so we got this as our output. Now for the differentiator circuit of resistance 2.7 kilo ohms and capacitance 100 nanofarad, we are plotting output voltage versus frequency, and we also plotted 20 log V0 by Va, which is known as gain, where the input voltage is 1 volt peak to peak, and this is our graph. Hello, Bhagdevi. Today I'm going to explain the frequency response of the integrator circuit. Here we have taken the resistance of 1 kilo ohm and the capacitor of 100 nanofarads. And here we have given the frequency of 2 kilohertz and 1 V peak to peak. In the sine wave, we have got the sine wave, and we have given the square wave. We are getting the triangle. By varying the input frequency from 500 to 1000 hertz, we are plotting the input peak to peak voltage with the frequency, and this is our V0 versus frequency graph. And we are also plotting 20 log V0 by Vi, which is the gain, where input peak to peak voltage is 1 volt, and this is our input gain versus input frequency graph. Next, we are going to make the integrator circuit using 2.7 k ohm resistor and 100 nanofarads capacitor. And we have taken the frequency of 2 kilohertz, 1 V peak to peak, and this is the wave we got. And when we take the square wave, we got the triangular wave, and we have taken a power supply of 12 volts. This is the data we got by using 2.7 kilo ohm resistance. By varying the input frequency from 500 to 10,000 hertz, we are plotting the output peak to peak voltage with frequency, and this is our graph. V0 versus frequency. And we are also plotting 20 log V0 by Vi, which is the gain, where input peak to peak voltage is 1 volt, and this is our gain versus input frequency graph.
My name is Rujan. Today I am going to explain the average value of two input sine waves. So we have given two inputs V1 and V2. So the input 1 here is connected to the resistance R1, and the negative terminal is grounded. And similarly for input 2, the positive terminal is connected to the resistance 2, and the negative terminal is connected to grounded, and we have connected a feedback resistance of R1 by 2 across the negative inverting terminal and the output. So as here we have connected R1 by 2, so I am connecting two resistance in parallel, so we will be getting a value of R1 by 2, and here the positive terminal is grounded, so Here I have grounded the third pin of op amp, and we have connected the resistance R2 across the output of op amp 1 here, op amp 1, and the input negative terminal of op amp 2, and we have also connected a feedback resistance to op amp 2 R2 from pin 2 to 6 pin, and at op amp 2 we have grounded it by using the power supply. So we have connected a power supply of plus 12 volts and minus 12 volts, which I have connected to the both op amps, and the negative is connected at the fourth pin and the positive is connected at seventh pin. And now, as per the given question, we have taken voltage of 1 peak to peak for 1 kilohertz frequency, and for second input we have taken 0.5 volts and a frequency of 3 kilohertz. We have taken resistance of 1 kilo ohm for R1 and 2.7 kilo ohm for the resistance connected for the op amp 2. We will be seeing an average voltage of V1 plus V2 by 2, where we can see here 712, which is nearly to 750, as we have given an amplitude of 1 volt peak to peak in channel 1 and 1 kilohertz in channel 1, and in channel 2 we have given a 0.5 volt peak to peak and a 3 kilohertz frequency, and for a phase of 79 degrees we have got the average value of 712 millivolts, which is an average near of 750. Thank you.